Yeah, so my name is Chris Rogers. I'm a senior technology evangelist at Zerto, and I'll say with me, but hopefully with everyone in the room. It's Justin Paul, a senior product manager at Zerto. So today we're going to be going over Zerto 10, which launched a couple of weeks back now. So the tagline for our release was real-time detection meets real-time protection. And I think it's a really cool tagline because essentially what we're bringing to the market, real-time detection, meets what we already have done and have been doing for a long period of time now, real-time protection. So in Zerto 10, we had kind of four key enhancements that we wanted to bring to market. And these are the kind of things I'm going to be showing and kind of explaining to you guys today. So real-time encryption ransomware detection, the Zerto cyber resilience vault, the Zerto secure appliance, and then protecting Azure at scale. So as I said earlier, launched a couple of weeks back, May 18th, and the GA date for this is currently June 13th. So not too far away now from being able to get hands-on with it and actually playing with it and everyone else getting into their environments. So I'm going to dig straight in to the real-time detection. Real-time detection comes in the first pillar here. So replicate and detect. When we look at the pillars we have on the screen in front of us, this is what we feel as Zerto helps us achieve ransomware resilience. So the first one being replicate and detect, the second one, isolate and lock, and the third one, test and recover. And that's hopefully going to enable our customers and prospects and partners and everyone else to enable continuous protection for any app, for any cloud, and any threat. So I'm going to go and dig into each one of those sections a little bit more, and you'll see the technology and kind of how we deliver those three pillars there and how they combine to achieve ransomware resilience for our customers. So the first one, ransomware resilience with Zerto, replicate and detect. So if we look at this diagram here, this is like a very simplified, revised version of the MITRE ATT&CK framework, which I'm sure people in the room and on Zoom and on social will be very familiar with. So if we look at typically what happens in a ransomware attack, we get that initial access, so via phishing or social engineering or however they manage to achieve access to systems. And then they move into what they call C2, so command and control. So taking over those systems and having actual control of them. And then we move into the lateral movement stage. They're not happy just having access to one system. They're going to be trying to map out what is available, where they can get to. And obviously, this is going to massively depend on each environment and potentially what time of day and what firewalls have been in and what microsegmentation is available in the organization, in the estate. Once they've moved laterally across and gone as far as they can do, they then move on to disabling security and backup agents. I think that's one of the key points is now they're not just going in and saying, I'm in and drop the bomb and leave. They're being a bit more strategic and saying, well, I know that backup is the way out. Therefore, if I can stop the way out, I leave them cornered, right? I don't leave them any room to wiggle or anything else like that. And also, if I can disable security monitoring systems and agents on VMs, then guess what? I potentially go undetected for a little bit longer as well. The interesting stat that I find here is the median dwell time is only 5 to 9 days. And that's from a Mandiant report in this year, which I actually thought was going to be much longer. But actually, 5 to 9 days kind of makes sense because the longer you're in there, the longer you risk being caught and then not getting a payday out of it, right? That's what they're here for, to get paid. So we understand that's kind of what's happening in this situation. And then we move to encryption and then to the recovery phase. So that's kind of what people are doing. But there's a key point in here where we don't actually know what's happening until what? So once the encryption's taken place, how do we know that encryption is happening? How do we know that something is wrong? Do we have to wait for users to notice that something isn't working or files are no longer accessible or our monitoring system to pick up that maybe something isn't quite right? But that can take time, and it also can take a lot of needless kind of figuring out what actually the problem is. Is it a network problem? Is it an application error? Is it a database gone down? All these other things that could be wrong with the application. Probably the first port of call isn't we've been hit by a ransomware attack. Probably it's all the other things first, then looking at what the possibilities are. So how do we detect if encryption has actually happened? Traditionally, when we're using secondary copies for doing ransomware detection, they're done on backup software, backup copies. So the first point being they're relatively infrequent, right? So most people, most organizations are going to be backing up maybe once, twice. If they're really keen, maybe 4 times a day, just because that's the nature of backup, right? We don't do them all the time. They're periodic snapshots, normally with some production impact, and normally happens overnight. Hence, we have a backup window. Normally can take hours, sometimes even multiples of hours, and even dozens of hours. Sometimes I've been in companies where literally it's 7 till 7, and that's the whole backup window. And then we start work at 8 again and finish at 6. And if it doesn't happen, it doesn't happen. So we have, the lengthy windows, and they normally have some production impact, slowing systems down. And then once we've taken that backup, we're storing it somewhere in secondary storage, wherever that may be. And then we have the scanning window. So they're scanning that large backup data set, and potentially relatively old if it's done the night before. And then we move into the recovery phase. So once we know that something's wrong and the scans pick something up, we're then restoring potentially large amounts of data because it's been quite a long time since we figured something out. And we're recovering large amounts of data with software that's designed for backup, which isn't designed to recover mass at scale. Essentially, what that leads us to is a longer RTO, a larger ransomware impact, so the actual impact of the ransomware, and therefore a higher cost. And when I say cost, dollar amount is probably the thing that comes up, and everyone kind of loves to shout about, and we see all the stats everywhere. That's sorry, all the stats for how many millions and billions of dollars going to be, but also things like reputational damage. And if you're in like healthcare, for instance, going to be patient care is the higher cost. It's not just about dollars, but all those other things as well. So if we look at traditional backup, how it's done, we're ingesting those files, folders, blocks, whatever it may be, and we have this loop of backup, scan, restore. That's how it's worked, and that's how it's working currently. But I want to introduce to you streaming inline detection. So Zerto, as the blocks flow through the Zerto solution, we're detecting encryption in real time. So once the blocks are flowed through the Zerto solution, we can then send alerts upstream, so to our own monitoring software, so the Zerto Virtual Manager, or even out via API to third parties if we need to. And then we can then go into the Zerto solution, choose checkpoints, do a test in an isolated recovery environment to see, was it actually encrypted? Has something happened to the environment? What is the blast rate of this? And then you can understand what needs recovering. And then you can do a direct recovery, however you see fit with the Zerto solution, back onto production grade storage and compute. You see that traditional backup, normally between hours and days, this process is going to take. So the backup and scan and the restore is going to be in that hours to days window. Where with Zerto, we're in that seconds to minutes into hours section to getting that whole system back up and running. Once it's been detected, alerted, tested, and then recovered. So hopefully that kind of makes sense as to the difference as how we're doing things. And we're not just doing things the same way and doing it quicker. We're doing it completely the Zerto way, if you will. We've always done things differently. We've always come to the market with a different way of approaching a problem. And this is how we're doing it with ransomware. So the idea of this is it gives organizations earliest warning sign that something is wrong. I completely understand. I'm sure there might be a question as, well, we've still got stuff that's proactive. 100%. We still need the proactive, capture the stuff before it gets in or as it gets in, or those signature scanning and everything else that we still need in that environment. Absolutely. But what happens if they're right once and we do get attacked? We need to know as quickly as possible because speed is of the essence in this time. So it's the first point of impact that we're going to see the first warning sign pop up. And then we're going to be able to help you identify the blast radius. And I'm going to go into that in a little more detail a little bit later on. But essentially, because if you know how Zerto works, you know how we combine virtual machines together that make up applications. Well, we're going to alert you on either the volume, the VM, or the VPG level, or the application level to what's actually happened. So we can be quite granular in how that's approached. So if you've ever seen a Zerto presentation before, you would have seen a slide probably similar to this. The architecture hasn't changed drastically since, as Stephen mentioned, the first iteration of Zerto that came out maybe 10, 12 years ago, something like that. So we have our Zerto Virtual Manager on the production site, and we have a virtual replication appliance on each and every hypervisor host in production site. We then mirror that across to the replication target. So Zerto Virtual Manager in that site, and virtual replication appliances on each and every hypervisor host in the replication target. And you can see between the VRAs, we have that encrypted continuous replication, or CDP is known in the marketplace. And essentially what we've added to the VRAs is the inline encryption detection and alerting. So actually adding it inside of the VRA. So the beauty in this is that there is no additional components or infrastructure required to enable this feature. There's no more hardware, no additional deployments, no additional even virtual appliances, nothing. If you're a customer running Zerto 9.7 today, and on June 13th you upgrade to Zerto 10, you turn this feature on, everything that you have in place today will work, and it will just be on and ready to go. There's no additional impact to having the VRA do the inline encryption detection either, so we don't even need to scale them up or scale them out either. And then the beauty is it is available at no additional cost with Zerto 10. So we are providing this free of charge to our customers. As soon as they upgrade, they get the feature. There is no additional licensing, no additional ransomware detection license, anything else like that. It is free of charge to our customers. And this is what it's going to look like inside of the UI. So if you see the Zerto journal before, you'll know replicating data every 5 to 10 to 15 seconds, something like that, depending on the environment. And then in the journal, we're keeping a log of those checkpoints as they go down from 1 hour all the way up to 30 days. But then on the right-hand side of this now, we're now going to tag inside of the journal when we think that something is a suspicious anomaly, when we feel that something has happened in the environment that is not normal and is not quite what we're expecting. So then when you go to do a recovery or you get an alert and you from Zerto or your monitoring solution or whatever, however you're getting your alert, you can come into the Zerto journal and then look at suspicious checkpoints in the journal. And then we'll also tag clean checkpoints as well from previous moments in time. So you can then either test the suspicious one to see in an isolated recovery environment to see if that is has been impacted by ransomware, or it's something that you're expecting. You know, someone's turned on something or something has happened, it's fine. You know, we can mark that as no threat. Or you could test on the clean ones and actually say, actually, the app is down. This correlates to what Zerto is saying. So I'm going to test a clean checkpoint and get my app back up and running from 10, 15, 20, 30 seconds ago, whatever it may be.
A question about the detection, if you don't mind. Just curious, what are the heuristics that you're looking for? Is this sort of like pattern differentials, amount of change, types of, detecting encryption where encryption didn't exist? Just, I know there's a lot of secret sauce inside it, but it is always interesting to hear what the top few are.
Yeah, I've got a slide on that later, a little bit kind of under the hood, but I can cover it. I can cover it now in a little bit more detail, and we can move on to that one. So essentially, we are looking at patterns. We have a learning phase inside of there to learn roughly what the environment looks like, and then we have benchmarks in our environments where we set, and it will trigger on those benchmarks essentially as to when we feel like something there. And we're using multiple different algorithms as well. So there's different levels of alerting. So depending on how many algorithms it matches against, will give you a different severity of alert. So if it matches all of the algorithms, then hey, this is probably most likely something is really bad is happening because every algorithm we're using thinks that something's happening. And if it's just matching just a few or just one, then we'll throw up a smaller alert as well. Again, kind of give you that insight. So a lot of secret sauce in there. I can't really go into too much detail in terms of how and what we're looking for, but essentially we're using algorithms to detect the change in the blocks as they flow through.
Is this doing the Kubernetes backups, or is that still VK4?
That's a different product. This is the VMware product.
This is just the VMware piece, right? Yeah, so like ZK4 is still doing the Kubernetes piece.
Right.
Yeah. Okay.
Yeah, so Z4K is still there, still running, still going. This is brought to the VMware platform to start with. So the first release of this came out on where the majority of our customers live, right? They're pretty much living in the VMware space, and we're replicating VMware to cloud and then cross cloud and things like that. So still with those, there's VMs or instances.
Got it.
So as far as underlay, then this is only available on a VMware base. It could be VMware Cloud on AWS or whatever, but it has to be VMware for this set of features at the moment.
The source hypervisor has to run the standard VRA. So right now that's VMware. We will probably look at the other hypervisors. We can go into detail on the difference, but the big thing is that the other platforms aren't more of a streaming IO filter. They're more of a snap and then find changes and then replicate. So we don't get them in real time like we do with VMware.
Right.
That's why we've started here. Plus, we have the horsepower to do it here, right? Because the VRA is being on every host. The algorithms that we're running are making decisions so fast that the workload that we're putting extra on the VRA is very, very small. Whereas in public cloud, where you have to pay for basically every CPU cycle that you use, and like I said, the way that we like on Azure, for example, right? We ask them to take a snapshot, and then later we ask them to take another snapshot, and then they have an API that sends us the change necessarily stream through us until we get that list of change blocks and then basically feed them to the other side. So theoretically, we could look at those change blocks once we figure out which ones they are and then read them. But we're doing a whole bunch of other stuff with Azure right now to re-architect our platform, and we didn't want to complicate it yet with this. So,
will there come a point? Totally okay if you can't answer, but will there be a point where you have the Zerto piece for VMs, you have the Zerto piece for the cloud, the Zerto piece for Kubernetes, and it's all under kind of one UI, one umbrella where you can manage it in one place versus having utilized multiple different Zerto products?
you have slides on GreenLake, Chris, or?
let me just see if I've got some hidden in a drawer somewhere. But
I just didn't know if there's any in this deck.
no, I've purposely stayed away from it. But yeah.
Okay, so
do you want to take that one?
yeah, sure, I'll take it. So Zerto became part of the HPE family 2 years ago now, almost, or something like that. And obviously they have the GreenLake platform, which they've asked us to integrate Zerto into. Zerto had always wanted to build like what we called a global manager for a long time. We kind of did it with our Zerto Analytics platform, but that was kind of a read-only analytics-based platform. There was always talk, like way back in the day, of at some point we'll make it read and write, meaning like we'll have APIs that you can then say, yeah, do a failover, and then Zerto Analytics would call your ZVM, and something would happen. We were always kind of gun shy to turn that on.
Right, got it.
But basically, we weren't there with security, right, with Zerto Analytics.
Gotcha.
GreenLake is very different. GreenLake is a two-way street, and when I do one of the demos on the ZVMA, I'll show you the agent that we have. And so the thing there is that at some point, GreenLake will become that single pane of glass for all customers. It's going to be a journey for sure. VMware will be the first platform that we bring to it. But the idea there is that it'll really become part of the HPE family. You'll be able to see us in the same tiles as your Aruba networking and your Electra arrays and all the other goodness that HPE has, including like the backup stuff, right? So Zerto came into the family as part of basically what we call cloud data services. So there's another team that's doing like traditional backup software. The idea is to put them in the same pane of glass, and then at some point maybe even integrate with each other. So,
Okay.
because we have the data, right, and so it wouldn't make sense for us to grab it twice.
Right.
So at some point, maybe we can do that stuff too. So kind of grand vision.
Yeah.
No timelines or anything like that yet, but that's certainly where we want to go, is single pane of glass.
Yeah, I'd imagine for larger organizations, having multiple UIs for, VMware, for the cloud, for Kubernetes, or even just multiple APIs, right? If we're trying to create repeatable processes with code, it could be a challenge for multiple teams.
Yeah, so we have a separate product manager for the GreenLake stuff, what we're doing, so I won't steal too much of his thunder, but that's one of the other great things about the single pane of glass is not just the GUI, but it becomes a single pane of glass for the API too. So when you want to do something through the API, and you would normally have to go and log into this ZVM and then go and log into that ZVM, now you just hit GreenLake and you can do assuming you have the right permissions,
Right.
You can do whatever you want to all of them.
Got it. Cool. Thank you.
Prepare for rabbit hole. I apologize in advance. So you may be already coming to it, but I'm going to take you there fast.
Sure.
So detection is one thing. What you do post-detection is, so especially when you get into situations like this, journaling detects anomalous behaviors occurred, heuristic figured out, now what? Do you then, at that point, then immediately make previous instances immutable? What's the activity that happens in order to make sure that now this anomalous behavior has been detected? What is system behavior, and then what is notification behavior for the operator.
Sure. So as Chris explained, we're going to, in 10.0, we're going to basically try to give you a really good idea of where you need to start looking, right? Zerto has never automatically hit the failover button for you, even if we know the source side is down, just because there's too many variables, right? We're going to do the same thing here, at least for now. Meaning we're gonna tag where we found the anomaly, and then we're gonna tag a checkpoint that we knew there was an anomaly. There's a lot of other reasons we're doing that. It has to do with how we start to consolidate checkpoints. We don't want to get a customer to the point where, yeah, we found one, but it was Friday, and then 3 days later we said, you must not want like every single granular checkpoint. So tagging them helps us do some things on the back end. But the idea is Zerto is a sea of checkpoints. They happen every 5 seconds normally. Trying to find exactly which one you need is a needle in a haystack. So first thing we're going to do is do tagging. We've talked to, and I'd love to get your guys' input on where we go next, right? I mean, theoretically, we have access to all the VMware APIs. So we could disconnect the network, we could power the VM off, we could do literally anything you can do as an administrator. We can do that automatically. It's just a case of, well, what is your normal response to ransomware, Mr. Customer? Like, do you normally just unplug the network cable? Is that the first thing you do? Do you disconnect your network, right? I mean, we're part of HPE. If you have Aruba, I mean, we could theoretically send a webhook call and say, hey, just shut off the internet. We can do lots of things. It's
Well,
I think what's too much.
Curtis, go ahead.
Well, yeah, I would think the one that we're really interested in is that recovery phase, right? So,
Yeah.
but I'm assuming that he's going to cover that.
Oh yeah,
next.
yeah. Go ahead, Chris.
You're gonna cover that. I'm guessing in a slide or two, the recovery phase.
I'm going to keep pushing them down.
It might be
Rabbit hole. We're not done yet.
Oh, okay.
Yeah, so yeah, I'll be covering recovery in the test and recover piece of the presentation. But great conversation, everybody. I'm really enjoying it so far. So, am I right to move on to the next slide?
Yeah, just one more thing. That the reason why I sort of bring up the idea of like tagging is interesting, and often the VMware admin in me that believes that I'm smarter than systems would think like, oh, let me use that tagging for ad hoc things, which it never really happens, because find me an environment that says they use tagging and I'll find you a bunch of untagged VMs. It's nature. But that's why I say at a system level, it almost seems like once that detection occurs, like you said, Justin, there's many things we could do, but my immediate thought is you should, at that point, immediately make the previous non-anomalous backup immutable. So there's no way, because assuming ransomware is already now in the network, it now is putting my VMA at risk, all my operations, my vCenter at risk, which then can take action on these objects, because the VMware administrative side can do things to these images that are naughty.
Yeah, so I think Chris has got a bunch of stuff in here on what we're calling Z-Vault. That's really where the immutable stuff comes in. But before we get there, let's just keep in mind that
we can.
No. What I was going to say is that
I'm going to pull you down that rabbit hole.
No, you're perfectly fine. So if we look at the architecture, Zerto is just VMs. We write to just VMDKs.
Right.
My response is, you guys see a lot more vendors than what I do these days, right? So find me VMDK storage that's immutable. That's kind of been the problem so far, right?
Right.
So if we had, which I don't know how much I can talk about HPE stuff, but if we had a storage array that could do immutable snapshots at the LUN level or whatever, sure, we could trigger one of those to happen, right? But right now, as far as I'm aware, in VMware, there's no way to just say, hey, take a VM snap and make it immutable, right? I don't think, ESX won't let us do that yet.
True, yeah. Or if it does, the same ransomware could go and tell vCenter to make it not immutable. And yeah, okay, no.
You're writing to a VMDK in the back end.
Correct. So basically, our VRAs, the way that I like to explain them to people is think of them like a storage array. They're a controller with disk boxes attached. Instead of like actual disks, we have VMDK files. So if something corrupts our VMDK files, yeah, we would be, in a bad spot. But Chris has a really great diagram on this thing called Z-Vault that we're introducing. Well, we did introduce it, which kind of kind of marries the HPE hardware along with the Zerto solution. You got to remember that we've always been all software, and we've always told people, well, whatever hardware you got, we'll run on. Now we can kind of say, well, we also have these cool toys that we can integrate with, and that's kind of what zVault is. So.
Yeah, well, very interested when we get to that part.
Yeah, one thing I just wanted to add to what JP said is all the metrics and all the alerting and the tagging and everything else we're doing is all available via API. I know Justin is going to go into this in a little bit more detail. So whatever you want to build using the API, you can build it, right? So unlike other competitors and things like that around, we're not being a closed shop. We understand that cybersecurity as a whole and ransomware is a bigger problem than just Zerto. We're not pivoting or focusing or saying that we're going to be a security company. Absolutely not. We're still a data protection company, heart and heart. We're still a DR, ransomware resilience, multi-cloud mobility company. So whatever actions you want to take, you can build those using our API and do whatever you want to do, right? So as soon as you see an alert, as soon as you see a tag checkpoint, you can then kick off whatever you want to do using that. So we're making those APIs available all the time. And that's kind of like a commitment we've made, is all those APIs that we've developed, let's make them available for people to use in other solutions as well, rather than just being, if you want to see Zerto data and you want to see a tag checkpoint, you have to log into Zerto to see it. Well, your SOC team or whatever, they're probably not logging into Zerto, right? It's not a cyber tool, it's not a security tool. But they might be logging into a SIEM system where we can send those APIs or that information to, right? So that's the idea of this for stage one, right?
Are the VMDKs encrypted at rest as well? Like, and obviously the traffic is encrypted in transit, but I'm curious. I'm sort of
we rely on the array or whatever hardware you're doing to do at rest.
Okay.
Now the journal is encrypted, right? So when we encrypted the source side, we never unencrypt until we try to use the data.
Right.
The base VMDK is not encrypted because that's basically a normal VMDK.
Right.
But all of our journal VMDKs aren't like normal. We use them as a disk, right? So we put data where we want. It might a single journal will have thousands of checkpoints, and it's not like in chronological order. It's kind of like, oh, we need to put a block somewhere, and so the journal disks are absolutely encrypted if you've got encryption on, which in 9, 7, and 10 it's on by default. So your journals are absolutely encrypted. Base VMDKs aren't, just because we're eventually going to give them back to VMware.
Right.
And
yeah, and it needs to be lit up, so VMware would have to have the key to decrypt and whatever. So yeah, So if the Zerto management, like the VRA goes away, can I bring that VMDK back online because it's not encrypted? Like so
the VMDKs aren't tied to a VRA. And in fact, if you lose a physical host in a VRA, we can just go into the system and say, hey, change the recovery host to a different VRA, different host, and it'll remount them, right? So the ZVM has intelligence to say these VMDKs kind of belong together, and they were on this VMDK or this VRA, he's gone. So remount them. So basically pull the disks out of this array, put them in this array, and they show up like they're supposed to, and we can keep going.
And what's done to protect the journal and replicate the journal to make sure that in case that something goes really sideways, that you effectively have a way to pull that journal to another location and at least say, hey, our whole first site just got ransomwared.
Still my question.
Oh, sorry.
So keep in mind,
I can cover some of those later on. I've got some slides on those. So yeah, so essentially this is the flow that we're expecting to happen, right? So replicating to the journal target of your choice, and as Justin mentioned earlier, that can be a cloud target as well, right? So when we're talking about the secondary site, going down, or the primary site being encrypted as a whole, well, hopefully, if we've got like a VMDK or an ESXi attack, for instance, if we're sending that replica and that journal data to Azure, AWS, service provider, they're hopefully not going to be hit by the same attack right at the same time, because it's going to be very complex to coordinate taking down your blob storage and your ZCAs and everything else. Not impossible, I will admit that completely, but it's going to be unlikely that an ESXi attack is going to affect and impact Azure at the same time, for instance. So that's one way we can help. And then we're then sending the metadata to security observability and analytics tools. So via the API, people can then hook in whatever tooling they already have or want to purchase in the future and pull all that data and suck all that data out of Zerto to make use of it how they want to. So then we're detecting those anomalies at the block level, and we're tagging clean and suspicious checkpoints in there. And then the idea is you would then go in and non-disruptively test and validate the clean checkpoints, right? So you using the Zerto failover or test failover, you'll be able to those tests within an isolated network, bring them up, see how they look. Great, yeah, they're clean, perfect. and then you can recover from those points, and then you can send all that data back out via the API to your monitoring, security, whatever tools you want to say. Yep, I found a clean checkpoint and I've recovered that data as well. Cool. So that's the idea behind the flow. So I kind of covered a lot of this already, but I'll give you kind of a quick run through. So we're reducing those false positives by utilizing multiple NIST accredited algorithms. I'll tell you what they are. That's the secret sauce and how we're doing it and everything else. That's what goes into making it what it is. But we're trying to reduce the noise, right? We're trying to reduce the point where people are so fed up of seeing an alert that they don't, the boy who cried wolf, essentially, it's they don't ever action anymore. So we're trying to reduce that noise. We have zero delay. So we're not delaying the I/O either from the VM to the storage array or even from the Zerto replication. So from VRA to VRA, there is no additional processing time, or any that there is absolutely minimal. You won't even notice that. So it's not as if your RPO is going to go from 5 seconds to 5 minutes because you've turned on encryption analyzing. You won't even notice there's a difference. So really important that we're not actually intercepting anything anywhere. And I have got a little diagram in the sec just to kind of show you the flow. We're doing that granular detection. So as I said earlier, we're identifiable at the volume level, the VM level, and at the virtual protection group level as well. And again, all the metrics are available via API or via the UI to pull that out on a volume, VM, and VPG level. And that's really going to help us kind of identify what's been impacted and roughly make a timeline out of what's happened. If we look at like a blast radius, for instance, if a tier 4 application suddenly pings up and says, oh, the whole app looks like it's suspicious, right? And you go, oh, that's weird, let me go check it out. And then a tier 3 app a couple of minutes later or a few seconds later starts pinging up, you're like, okay, now I need to make sure my tier 1 and tier 2, tier 0 apps are protected from this because it looks like it's coming up the stack, right? We can help you identify that blast radius without having to kind of recover everything and then try and pick out the good from the bad. And as JP's already mentioned, everything's analyzed at the source site. So you don't even have to have a secondary site if you don't want to. If you just want to use Zerto for a local replica in its own little bubble, do encryption analysis, just locally back to itself, that is a fully supported system, as is replicating out to clouds as well. So AWS, Azure, the VMware on public cloud offerings as well. So if we looked at the replication overview, the dice diagram hasn't actually changed from our normal one. I've just added an extra bit in it. So as the VM sends data from the hypervisor down to the storage, Zerto normally always has done, always will do, essentially intercepts it in the hypervisor memory, takes a copy of it into the local VRA's memory buffer, and once we have it inside the VRA, normally what we do is we wait for the acknowledgement to come back from the storage array, and then we send it across. So whilst we're doing that, this is where we're doing the encryption analyzing inside the source VRA. So the data hasn't got to change its path to where it would normally go in the normal Zerto solution. And then once we've analyzed the data, we send it across compressed and encrypted. We add it into our journal, so anything from 1 hour all the way up to 30 days, and it ages out into the replica disk, like Justin mentioned earlier. That essentially is happening for all the change blocks, all the VMs and all the apps that you've got protected by Zerto on an ongoing basis. No delays to the I/O. We're not intercepting it or reading from the storage array, which I think is a massive bonus. And if you know anything about Zerto, that's always been the way. We're not trying to slow down things. We're trying to do things as quickly as possible. So to kind of summarize this section, if you will. So it's real time as you're going to get it. The earliest warning of the encryption phase of an attack. Again, we're not a cybersecurity company. We're not looking at signatures and files and looking at metadata and things and trying to tell you if something looks suspicious before it's happened. We're telling you this looks like something is encrypting your data. You might want to look at this before it spreads massively throughout the environment. We can help you identify that blast radius, as I mentioned, by giving you the metrics on the volume, VM, and VPG level, and understanding if all your VPGs have alerted at the same time, guess what? Probably all your apps are going to be impacted. If only 1 or 2 have, you've got that information there to kind of understand which ones look like they've been impacted and which ones haven't. We're going to minimize that data loss by enabling your IT operations or your security operations team to take action mid-attack. So it's not after the backup's been done or been scanned or when a user ticket comes in. So hopefully we'll alert you mid-attack when, hopefully at the beginning of the attack, and it allows you to kind of maybe pause or break or stop the attack from happening and being as bad as it could be. I mentioned the API already. We've kind of covered that in quite a lot of detail. I know JP is going to cover some stuff in a second. But essentially, being open with the cybersecurity solutions and saying, use the data that we've got. We've got a load of data happening in near real time. Whatever you want to do with it, use it, right? Make a dashboard, make an alerting system, do whatever you want to do with that. It's only going to help. And again, no additional infrastructure, no additional impact, or no impact to production workloads, and no additional cost in Zerto 10 as well. So